In this problem, we're told a block of mass m equal to 5.8 kilograms is pulled up a 25-degree incline as in this figure, with a force of magnitude F equals 32 newtons. Find A, the acceleration of the block if the incline is frictionless, and B, find the acceleration of the block if the coefficient of kinetic friction between the block and the incline is 0.1. So this right here is the incline, right? And so we have this incline of theta, which is equal to 25 degrees, right? And then we have this block being pulled up by a force, right, which is mass 5.8 kilograms, and the force is 32 newtons. So we're trying to solve for acceleration in two different cases. One where there's friction and one where there's not, right? So in the case there's friction, right, where mu sub k, right, the coefficient of kinetic friction is equal to 0.1, right? And so let's just go ahead and start with case A. So for A, we're trying to find the acceleration if the incline's frictionless. So how do we do this? So for both cases, the first thing you always want to do, right, is just label the diagram. So for the first case, right, we're going to have mg, which is just the force due to gravity, go straight down, right? So mg just goes straight down regardless of the incline. And then F sub n, the normal force, is going to go up like this, perpendicular to the incline. So it goes up like this. So it's going to be straight up. And so we know that. And then we also have this force acting this way, right? So these are going to be the three different forces acting on it for the first part. So how do we solve for this? So the way we do it is by finding the sum of the forces in the x direction. And you'll see why this works in a second. But what do we know about the sum of the forces in the x direction? We know it's going to be equal to ma, right? The resultant force is equal to ma, okay? And so we know it's a, right? And not sometimes it's 0, but it's not 0 because it's actually accelerating, right? Because we're finding the acceleration and when it makes sense if it's 0. So yeah, sum of the forces is equal to ma. So you set it equal to ma, and then we need to find the sum of the forces in the x direction. So what are the different forces acting in the x direction? So when I'm talking about the x direction, if you label it like this, right? So imagine this is the axis, the axi or whatever. So the x direction is all the forces acting along this line, right? So even though it's curved, we denote this line as the x-axis, meaning F is a force that's acting in the x direction, right? So just keep that in mind. So ma is going to be equal to what? So what are the forces? So we also, just like an axis, if it goes this way to the right, it's positive. If it goes down, it's negative. If it goes to the left, it's negative. If it goes up, it's positive. Meaning, so ma is going to be equal to F, right? F is going in the positive direction, therefore we make it positive, right? Are there any forces acting in the x direction? So not explicitly, but there is. So mg, right, even though it goes straight down, it's going to have an x and y component, right? So imagine, it's kind of hard to, it's small, but imagine it's like this, right? So the x component is going to be this part right here, this line essentially, right? Because it's going in this direction, right? And so this is just going to be the x component of the force of gravity. So how do we find what that is, right? Because we don't know what it is, we just know that this part is mg. So how do we find that? So the way I look at it is like a triangle, right? So imagine this is this triangle, okay? This angle right here is the same, is just something you need to know. This angle between this perpendicular force, right, versus mg is the same as this incline, meaning this angle right here is 25 degrees. And so basically I'm just replicating this triangle. So this is 25 degrees right here. mg is this line right here, you say. So this line, the straight down line, which is the hypotenuse, which is this line right here. Okay, so that's mg. And then this line right here, x that I'm drawing, is essentially this right here. So what we want to do is find x. Or sorry, I'm sorry about that. We're trying to find y. We're trying to find this side right here because we want it in the x direction. This one's in the y, which we don't need. We need the x direction one. So essentially what we're trying to do is solve for this line right here, okay? And so this line right here is the same as this line, right? So I can label this x, right? This line right here, if I label it y, is this one, right? And you know that because this one right here is adjacent to our angle and this one's adjacent. So we want to solve for x. And so the way we do that is we know the sine of an angle, in this case it's 25, is equal to, so it's SOHCAHTOA, right? So the opposite over the hypotenuse. The opposite is x, right? So it's equal to x over the hypotenuse, which is mg. If we multiply both sides by mg, we can go ahead and get x. And isn't that what we were looking for, right? We're trying to find the x component of the force of gravity, which is mg times the sine of 25. So what we do is we minus, since it's going in the negative direction, mg times the sine of 25, right? Because that's the x component, or the one that's going in the x direction of our force of gravity, right? And so if we want to solve this, ma is equal to the force, which is this one right here, which they tell us is 32 newtons, minus m, right, the mass of our box or whatever, yeah, the block. So 5.8 multiplied by g, which is just 9.8 meters per second squared, right? That's g. And then multiply that by the sine of 25. Right? This is just the acceleration due to gravity. And then if we want to solve for a, just multiply or divide both sides by m. What's m? 5.8. So divide both sides by 5.8. Essentially, you just create an equation that you can use to solve for, right? So the acceleration, if you go ahead and do this, 32 minus 5.8 times 9.8 times the sine of 25, and then go ahead and divide that by 5.8. And when you go ahead and do this, you should get A is equal to 1.3755 and so on. I'm just going to round to 1.38. So 1.38, and then the units are meters per second squared. Right, that's acceleration. So 1.38 meters per second squared. That's going to be the acceleration of our block if it's frictionless. So that's A. Let's move on to B. So B, the thing about B that changes is now we have another force acting on it, right? So we have the force of friction, right? And so if it's traveling this way, the force of friction always acts in the opposite direction of the motion, meaning friction is going to be acting this way. So essentially, we're just going to do the same thing as the first part, except for we're adding another force because there's another force in the x direction, right? So there's this force of friction, right? We don't know what it is yet, though. So what we want to do first is, right, let's actually just do this first. So some of the forces, again, equal ma, right? So it's just the same thing, equals ma because it's moving. Ma is equal to, and let's label the forces. So we have this force, right, in the x direction. It's positive. So it's going in the upwards, right, which is positive. So F is positive. Minus, we still have mg times the sine of 25, right? We have that. That's going negative, right? It's negative because it's going downwards. And then we also have minus the force of friction, right? We have another force going this way, right? So we need to find all these. We have F. We know all these, right? But we don't know the force of friction. So we have to solve for that. So how do we do that? So the formula for force of friction is equal to mu sub k times F sub n, okay? That's just a formula you have to memorize. So force of friction is equal to mu sub k times F sub n. We're given mu sub k though. So we need F sub n if we want to really find this force of friction, okay? And so how do we find F sub n? So F sub n is this force right here. In order to find the normal force, you need the force that's exerting downwards this way, right? So basically you take the sum of the forces in the y, right? Let me do it over here. Sum of the forces in the y, and we know it's going to be equal to 0, right? And this one is equal to ma because it's accelerating that direction. And this one, it's not moving at all in the y. Keep in mind, we label the axis as like this, meaning it's only moving in the x direction, not at all in the y. So since it's not moving in the y, velocity is 0, meaning f sub y is 0, right? Because acceleration is just, right, it's a component of the velocity essentially, right? It's related, so if that's 0, acceleration is 0. So it's equal to 0. Now what are the forces in the y? We have f sub n, right? And since it's positive, we label it positive, right? It's going upwards, so it's positive. Minus, and then we need this force right here. Just like we did it in this one, right? The x, we need the y one. So what is it in the y? So think about, we solved for x last time, right? So we need y. So how do we do that? So just like last time, except for we're going to use cosine. So the cosine of an angle, 25 in this case, is equal to y, which is what we want, this line right here, over the hypotenuse, right? Because cosine is adjacent over hypotenuse. The adjacent is y. So the adjacent y over mg, right, which is the hypotenuse. Multiply both sides by mg, and now we have y, right? Mg times the cosine of 25, right? And so y was this force right here, right? So that means f sub n minus mg times the cosine of 25 is equal to, or f sub n minus mg times the cosine of 25 is equal to 0, right? And if we just add it to the other side, f sub n equals this, mg times the cosine of 25, right? And so if we know f sub n, right, we know mu sub k, we know the force of friction. If we know the force of friction, we can just go ahead and solve for a. So yeah, so let's just go ahead and start plugging stuff in. So we want to divide both sides by m, right? So if we do that, a is going to be equal to the force, right, which we know is 32 newtons, minus mg, the mass is 5.8, times g, 9.8, times the sine of 25, minus the force of friction. What's the force of friction, right? Mu sub k, which is 0.1, right, multiplied by f sub n, which is mg times the cosine of 25. So 5.8 times 9.8 times the cosine of 25, right? And so keep in mind, yeah, like this. You can put parentheses if you want, it won't make a difference. But yeah, all this divided by the mass, right, which is 5.8, right? So you're going to want to go ahead and plug this in your calculator. So 32 minus 5.8, right, times 9.8 times the sine of 25. Then you're going to minus 0.1 times 5.8 times 9.8. Multiply that by the cosine of 25. Right? And then you're going to want to go ahead and divide that number by 5.8. And so when you do that, you're going to get A equals 0.487 0.400783 and so on. I'm just going to round to 0.49. So the 8 just goes to a 9. And so keep in mind the units, right? So it's equal to 0.49 or about 0.49, and then it's meters per second squared, right? So this is going to be it with friction. So as you can tell, it slows down, right? It accelerates much slower because friction, right? And that makes sense because friction is going to make it travel slower because there's another force in the direction or the opposite to the direction it's traveling. So yeah, this is your answer to A, 1.38 meters per second squared. This is B. And so yeah, these are your answers, and hopefully you found this useful.